All right, so welcome back to the section today. They want to take into account matrices as part of the key topics when it comes to quantitative methods. So if you just joined, go to subscribe, like, and share. Most importantly, share the video so that others will get a benefit in that case. Right, so I want to begin right away without wasting. Let me bring up my screen. Get going. That line. Bring up my screen. Any question you want to throw it in the chat for us, I will answer it for that case. All right. So we are going to look at what matrix as uh, the topic and the quantitative methods for today. So do all to like the video and share it as well, so others can get benefit from this lecture in that particular case. Sorry about that. What happened? So welcome back once again to the section for today. So today we want to look at quantitative metrics as part of our discussion for today. All right, so let's begin without wasting my time. So today we want to look at what metrics, right? So we're looking at what metrics. Metrics is in business or application. In business application. I want to bring it up a bit here so I can put it. Metrics in business application. All right. So before we look at the business application part of this discussion, we want to have the fundamental idea about what a matrix actually entails. So matrix is a plural form of what a matrix. A matrix, something like this. So when I see it of this is actually a singular form. The plural form is what? Matrix. Right. So what is a matrix? So when we talk about a matrix or a matrix actually, right, is a rectangular array consists of what? An element or entries with respect to rows and what? Columns. So a rectangular array, so this can be the rectangular array, something like this. And within the rectangular array, we have what? An element, or we can also call it what? Entry. So we have, let's say, A, B, C, right? D, E, F, G, H, I. So these elements that you see, or these alphabet that you see within the matrix is called what? It can be called an element. So each value is called an element or what? Entry. But when we are looking at them together, we call it what? Element or entries. Okay, so that is what a matrix actually is about. It is what? A rectangular array of what? And entries or elements arranged in the form of what? Rows and columns. So what is the row? What is the column that we are presenting here? So by row, this is what we mean by what? A row. A row. So this is a row. So we can say this is what? Row 1. Okay. We can have what? here as what, row 2. Then we can also have the same here as what, row 3. Oh, sorry, row 3. So consists of rows and what, columns. So the column is going to be what, this form. So you may have a column in this dimension. This is a column. So sorry about that. I don't think you can see this. Let me go for blue if you can see that. Okay, so we can say that this also what, column 1. Then we have here to be what, column 2. Then we have here to be column what, 3. So that is the issue about matrix. A matrix is what, a rectangular array of what, elements or entries consists of what, rows and then columns. And that is what we indicate. So by a row, we are stretching up with what, horizontal. By a column, we are having a vertical line indicating that line. So once you have gotten that, that is how we represent elements or in a rectangular array form. So that means that if I have, let's say A, if I have A to be equal to 2, 1, 4, 3 in this form, I can say that A is what, a matrix. Why? Because A, as being a matrix, have what, rows and then columns. So you may have what, 2 rows, 2 columns. So by that too, we can also look at the size of a matrix. We can look at the size of a matrix. So by the size of a matrix, we are taking into account how many rows that we have, how many columns that we have, that determine the size of what, a matrix. How many rows that we have, how many columns that we have. So for instance, if I have what, matrix A that you can see here, you can clearly see that this matrix consists of what? Consists of what? 2 rows, okay? Consists of 2 rows, all right? And what? 2 columns. So you may have 2 rows, 2 what, columns. So by that way, we can say that this is what, a 2. This is a 2 by 2 what, matrix. A 2 by 2 matrix. A matrix in terms of its size denoted by a form M by what, N, where M stand for what, the row, and then the N stand for what, the column. The column. So this is how matrix size are also determined. So if I have a matrix of this form, let's say I have what, B, matrix B to be 2, 1, 3, 2, and let's say negative 1, 4. This is also a matrix because here we can determine the order. We can say that it has what, how many rows? We have what, 3 rows. We may have 3 rows, okay, and then 2 what, columns. So 3 rows, 2 column, 3 rows, 2 what, columns. So by the order of this matrix or by the size, we have what? We have what we call 3 by what? A 2 matrix. 3 rows, 2 columns. So that is how we determine the size of what? A matrix. So by the order of the size, we can have that. So that means that when it comes to the size, also play a very key role in respect to matrix operations. And by the operations of a matrix, we are going to look or take into account addition, multiplication, and possibly subtraction, right? So we look at these 3 aspects of what? Matrix operation: addition, multiplication, or addition, subtraction, and then multiplication generally here. So that means that when it comes to the size, it play a major role with respect to how the operation is supposed to what, be at the end of the day. So that is what we need to understand. So that will lead us or usher us into what? Addition and then subtraction of what? Matrix before we look at the multiplication part and we move on in that particular case. So let's discuss a bit about addition and subtraction. Addition and subtraction. of matrices. Addition and subtraction of what matrices that we may have as part of our discussion. Let's see how we can flow with that. So addition and subtraction of what matrices. So by addition and subtraction, all that we want to do is to what deal with corresponding what entries or elements, corresponding entries or elements. So what does that mean? Let's say I have matrix A to be equal to, let's say A, let's say, okay, let me go by this form. Let's say I have here to what A1, A2, A3, and then A4. And I have matrix B to be equal to B1, B2, B3, and then B4. B1, B2, B3, and then B4. If I'm asked to add this word or subtract these two matrices, that means that the order is very important for me to add or subtract. So by addition, if I should add A plus B, that means I'm going to deal with what? Their corresponding what? Elements. So you see where they are positioned. You can see where A is and where that of what? B1 is. Where A1 and B1 is. So we are going to look at their corresponding positions with respect to the elements, and we either add or subtract depend on the requirement of the question. So here we'll say that we are going to add. So we have what? We will have A1 plus B1. Okay, that are going to be the first element in that particular column that we're going to row that we're going to have, whether a row or column, because we can see it as what a one element here, so we can occupy a row or column. Then we can also have what, let me check out this, give me a sec, let me check out this, so that you can, any question you may have, can drop in the chat for me. Open up this. That's fine. Okay, so let's continue on. So that is the idea we are present when it comes to what addition. So we have A1 added to what? A1 added to B1. Then we follow the same suit. Can clearly see we also have what A2. So A2 will also be added to what? B2. So they are corresponding element that we are going to what? Deal with, right? B2. Then we will have what? A3 being added to what? B3. Then lastly, we may have what? A4 being added to what? B4. So you can clearly see that at the end of the day, when we are dealing with a particular order of matrices, the result should be within that same word order. So here we're dealing with what addition of what a 2 by 2 word matrix, and that should result to what a 2 by 2 matrix. But as we move along, you get to know that we're going to combine in some matrices in which their order are different, especially the multiplication issue. But at the end of the day, it's all going to result to the order we will expect to have. We'll get to some of these issues going forward. So that is the addition aspect, and certainly it's the same thing for that of what subtraction. So I can indicate here plus or minus, meaning that we can add or what subtract. So let's take an example to clearly, explain what we are trying to say generally here. So let's say I have matrix X. Matrix S is equal to what? In a 2 by 2 matrix form is equal to 2, negative 1, 4, 5. And then matrix Y also is equal to 6, 4, 2, let's say 2, 3. So we are asked to find I X plus what? Y. I X minus Y. And then last one, I. We are asked to find what? 3 into bracket X minus Y. So how do we go about this? Very simple, straightforward, because we have discussed this already. So here we're going to add or subtract corresponding word element in respect to that. So what do we do? I can straight up answer it here. So let me build up my matrix generally. So I'm going to add them without repeating the numbers again. So I'll be adding what? 2, right? With what? 6. Or we can say that 2 with 6. So that means that 2 plus 6 is supposed to get what? 8. So I have what? 8 here. Then second one, I'll also be adding what? So first, you just have to deal with what? The row element of what the 2 or 3 measures that you may have, whether it's an addition or subtraction. You just want to take it from that end before you continue with the second row. So the first row, we do the first rows, and then you proceed to the remaining ones as you move along in that particular case. Then we come to that of what? -1 will also be added to what? Positive what? 4. Okay, so that means that -1 plus 4, we are getting what? Positive 3. Then you do the same thing. Here we have what? Here we have 4 being also added to what? 2. So what are we getting? We are getting 6. All right, we are getting 6. And then that of 5 2. We also add 5 to that of what? 3. And we are getting what? 8. So this is by the order of what? Addition. By the order of addition. So when it comes to subtraction too, you follow the same rule. We are going to subtract generally there at the end of the day. So what do we do? Try to put this down a bit so we can create a space for this. So by subtraction two, we do the same thing. We subtract corresponding element or entry generally here. So now we are subtracting. So we subtract 6 from 2, supposed to get what? -4. Okay. We also subtract 4 from -1, we are getting what? -5. We subtract 2 from 4, supposed to get what? 2. Subtract 3 from 5, supposed to get what? 2. Right? And that will give us what? Our x minus what? Y. But the third one here that you can see, all right, next one generally here is saying that 3 multiplying x minus y. That means that now 3 is actually a scalar multiplier of what? X and y. And that will lead us into what we call scalar multiplication of a matrix. So let's discuss scalar multiplication of a matrix. Scalar multiplication. Scalar multiplication of a matrix. Of a matrix. So by scalar multiplication of a matrix, it is what? A matrix where we have a scalar, which can be, it can be what? A fraction, it can be a whole number, it can be a decimal, multiplying what? Individual elements in the matrix. Individual elements in the matrix. So here, based on our example that we are discussing, right, we can say that, okay, let me define the rule first before we come back to link up with the example generally here. So by scalar, we can say that if I have matrix what? A to be equal to, let's say, A is equal to P, Q, R, let's say X here, okay? And we have a scalar, say K. So by the order, if I say that K dot A, I mean that K should multiply what? Matrix what? A. K should multiply matrix what? A. So what do we do? All I want to do here is to say that now K will come in to multiply what? The matrix A. So what do we have? Matrix A, we have what? P. We have P. We have Q. We have R. We have what? X. Okay. So we can say that we will have what? Individual elements will multiply, or K as a scalar will multiply individual elements. So we will have what? First one, K. KP, right? Then we have what? KQ. Then we'll have here to be KR, and we also have here to be what? KX. And that will give us what? The scalar multiplication of matrix what? A. This is how it works. So by scalar, it can either be a whole number, fraction, or a decimal. Just use that to multiply the individual elements within the rectangular array, whether it's 2 by 2, 3 by 3, or whatever order or the size of the matrix that you want to understand generally there. So that is a scalar. So let's get back to our example that we're discussing here. Let me try to copy this one here, bring it up here, and let's see what we can. So you can clearly see that based on this example that we're solving, we are able to compute for what? X minus y. This is x minus y. So we can bring in x minus y here again. We can bring in uh x minus y, which is this. Let me copy this, bring it up here. So this was our x minus what? Y result. So if you are asked to find what? If you are asked to find what? 3 multiplying x minus y, then straight up we can say that this should be what? 3 multiplying what? Matrix -4, -5, 2, 2. Okay, so what do? We have here as what? 3 multiplying 4, we are getting what? -12. Okay, 3 multiplying 5, that's -5, we are getting what? Negative what? 15. Then 3 multiplying 2, you are getting 6, right? And then 3 multiplying 2, you're also getting 6 there. And this will define what? Our scalar multiplication of what? A matrix that we need to understand generally there. So that is the addition and subtraction and scalar multiplication of what? A matrix. So the next thing you want to look at is also to take into account multiplication of a matrix. If you have any question, you can drop in the chat for us as we take the discussion going in that particular case. So that is the whole idea that we are trying to present here when it comes to what? Matrix and its related issue. So let's discuss multiplication of a matrix. Multiplication of a matrix is generally there. Okay. So by multiplication of a matrix, here we also deal with multiplication of what corresponding what elements. So let's create a scenario there where we can easily apply them straight up. So let's say we have what? Matrix A to be equal to A, B, C, and D. And let's say we have matrix B to be equal to what? X, Y. Or let me chip in, say P, Q, R, and X. So these are matrices that we have. So we are asked to multiply these two matrices. When it comes to multiplication, you just want to be careful with that because it is one of the issues that once you mess it up, you get it wrong. So you will see A, B. You will see AB. By the order of multiplication, if I multiply AB, it's not the same thing as what? BA. Take note. When I multiply A and B, it's not the same thing as what? B and what? A. All right, so you want to take note of that. So let's see multiplication of A and B. So by the order of multiplication of A and B, this is what we want to do. Follow carefully. Here, we will first take the first row of the first word matrix to multiply the first column of the second word matrix. So we'll take into account the first row of the first matrix to multiply what? Come in, let me check up something there. Give me a sec, let me check out something here. There we go. this is what I was saying. I think I turn off my mic. Turn off my mic. This is what I was saying, that when it comes to the multiplication of the matrix, we will have what? Matrix what? The first row of the matrix. Yeah, I've sent it, don't worry. I think I'll check it out. We will have what? The first word row of the first matrix to multiply what? The second, should I say the first column of the second matrix? Let me take it again. That we will take inward the first row of the first matrix to multiply the first column of the second matrix. Okay, that is how it's supposed to work. Be. That is how it's supposed to work. Be. That's how it's supposed to work. Be. All right. So we have what? The first word row of the first matrix to multiply the first column of the second matrix. So that means that we will have what? A to multiply what? P, and that will give us what? AP. Then we say plus, then we have B to also to multiply R. And as I said, that will give us what? Just the first entry of the result. Just the first entry of the result. That is positioned on the top left corner of the array. And the same word row of the first matrix, you then come to also to multiply what? The second column of the second word matrix. So use the same row to multiply that so that we get what? The elements of the row on the result, right? So here too we will have what? We will have what? A multiplying what? Q, right? So we get what? AQ. We get what? AQ. Then we say plus. Then we have what? B to multiply what? X. So we get what? BX. BX in that particular case. So that would define as our row for the result matrix, for the result matrix, which is what? The multiplication of what? A and B. Okay. So once we are done, then we'll come back and say that, okay, then we'll have the second word. We'll have what? The second word row also to does this, also to second row to that's the same activity that the first row did in that particular case. So C also multiply P and then what? CD also multiply P and what? R. So we'll have what? Let's flow with that. We'll have what? CP. So we'll have CP, okay, plus D what? R. We'll have CP plus DR, and that would define what? The how should I say? That would define the entry of the second row position on the left corner of the result word array. The same row of the second matrix also multiply what? The second column of the second matrix. So that means they also have what? C multiplying what? Q. So we have what? CQ plus, then D also multiply what? X. So we get what? DX, and that will give us what? The result after the multiplication. All right. So that is the whole idea that you want to understand when it comes to what? The multiplication generally here. So let's take an example to make more meaning of what we are trying to actually unravel here. So let's say we have what? Matrix what? P. We have matrix P to be equal to -4, 3, 1, -2. And we have what? Q to be equal to 3, 7, 5, -1. Now we are asked to find what? PQ. We are asked to find PQ. Find I, PQ, II, QP. Okay. And then III, 3, III, 1/4, PQ. We are asked to actually work out this. How do we go? As I said earlier, PQ in matrix It's not the same thing as what? It's not the same thing as what? QP. It doesn't work in that way. In matrix application, commutative is not possible. Commutative is not possible. It doesn't work in that way. So you make sure that you don't conclude that, then you need to reverse everything. That is wrong. You get a different result in that particular case. We see if that principle that is saying is actually true, but it is true generally there. Okay. So what do we do? Let's go. PQ. So straight up as I engage with the first one, the same thing that I would do here. So straight up we go. So we take into account what? We take into account the first word, the first word row to multiply what the first column of the second matrix. The first row of the first word matrix to multiply what? The first column of the second word matrix. So let's flow and see what is expected of us to generally do. Okay. So what do we do? So we take into account -4 multiplying what? 3. So -4 multiplying 3, what are we getting? We're supposed to get what? -12. Then we say plus, we are not done. Then we have 3 also multiplying 5, we are getting what? 15, positive 15. So we have that generally presented word here. Okay. Come on. Then with the same rule of the first matrix, also go for the multiplication of the second word of the second colon of the second word matrix generally. So what do we do? The same approach, you don't change it. So -4 multiplying what? 7, we are getting what? -28. Then we say plus. Then 3 multiplying -1, we are getting what? Negative. So we are getting -3 here. So negative will take precedence of positive. So we have what? -3 here. So once we are done with the first row of the first matrix, we then consider what? The second row of the first matrix to do the same activity as the first one did for us to get what? The second row of the result what? Matrix, which is what? PQ. Okay, so straight up, what I want to do is to take into account 1 multiplying what? 3. So we have 1 multiplying 3, we are getting what? 3, and we say plus. Then we have what? -2 multiplying 5, supposed to get what? Negative what? 10. But that would negative, when negative and positive meet, the negative take precedence of the positive. So that means that we have here to go negative or 10. I mean, it influences the positive generally there. Okay. And then the same thing, we have 1 multiplying 7, we get 7 here. And we have what? Negative what? 2 multiplying -1, we get positive 2. And at the end of the day, what do we get in summary or overall? We'll say that here we're going to have here as what? 3. Hope I'm right. Then here you have here as what? 31. Then here you have here as what? -7. Then you have here as what? 9. So this is going to be your result matrix generally there. Your result matrix generally there. So the same approach you're going to use is also to deal with what? That of what? QP. That of QP. So I will leave that for you. Work it out, drop your answer in the comment or the chat section, and let's see if you actually get it right. So once we are done with that, then we can also deal with what? That of what? The third one, which says that we have 1/4. We have what? 1/4. Okay. We have 1/4. Okay. We will have what? 1/4. So this 1/4 is actually what? A scalar. So it will multiply what? Matrix what? PK, which is we know as what? 3. We know as 3. Negative what? Then -7, 9. Okay, so what do we get? So here we said that scalar will multiply individual what? Elements in the matrix or individual entry in the element. So we have what 1 over 4 multiplying 3, we are getting what 3 over 4. 1 over 4 multiplying what negative 31, you'll be getting what 31 over 4. Then 1 over 4 multiplying negative 7, supposed to get negative 7 over 4. Then 1 over 4 multiplying 9, supposed to get 9 over 4. And that will define what our result matrix in a 2 by 2 approach, right? So that is how multiplication also works in that particular case that you want to really understand. Okay, so that is the whole idea that we want to understand when it comes to the multiplication of what a matrix. The next thing that you want to look at is also the issue about what determinant of what a matrix. We want to know the value of the whole matrix. If we want to represent as a single value, what do? We find the determinant of that matrix. To find a single value of a matrix, one of the ways we can do that is to find the determinant of what that matrix. So what do? Determinant of a matrix is also something that you also need to take into account. So let's discuss determinant of a matrix. Any question, drop in the chat for us. Determinant of what? A matrix. Of matrices generally there. So let's flow. So by determinant of a matrix, that's what we are saying. Let's say if I have what? A to be equal to what? Let's go for PQ, R and what? X. Let's say RT. Let me go for PQ, RT. Okay, this is my matrix. This is a 2 by 2 matrix. I'm asked to find a single value to represent what the whole matrix, what A. What do? I'll find determinant. So by convention in maths, we can write determinant as what? Det. So by the short form det what? A. And in finding that A should be equal to what? The product of the upward compared with the product of what? The downward. So let me go by this way. When you are finding determinant of a matrix, all I want to do is that we're going to do a cross bar approach here. This is what we're going to do. It's very simple. You have what? A downward approach like this. A downward product like this. Okay. Better, so let me use this for you. So you have what? A downward approach. Oh, sorry. What I want you to do, is it this? Okay. You have a downward approach like this, right? You find the product of what? The downward word entries, and then you compare it with the product of the upward word entries in terms of their product. Okay, so that means that if you want to find determinant of A, we will say that determinant of A should be what? PT, right? The multiplication of what? PT, compare with the multiplication of what? RQ. And that will give us the determinant of what? A matrix. That will give us the determinant of what? A matrix. All right. So that is also another thing that you want to really understand when it comes to determinant of what? A matrix. So once we know the determinant of a matrix, we can also apply this same principle in what? A 3 by 3 matrix. Okay. So let's say I have what? Let me bring that one here. Let's say I have X. And within the X, I have A, B, C, D, E, F, A, B, C, D, E, F, G, H, I. If I'm also asked to find the determinant of this 3 by 3 matrix too, the same approach. But when it comes to the 3 by 3 matrix, this is the second or the alternative method of finding determinant. And I always want my students to learn this approach because it's always very simple to go without any difficulty. All I want you to do when it comes to 3 by 3 determinant of matrix is to repeat what? The first two words, is to repeat the first two columns of the original matrix in addition to extend what? The original matrix. Let me take it over again. And when it comes to determinant of for the 3 by 3 matrix, all I want to do as being the alternative method, all I want to do is to repeat what the first two columns of the matrix to extend or to extend to extend what the original matrix. So you're going to add it up to what. So what do? We will say that by extension we will have what an adjustment of what matrix what x, I mean being a new matrix that we're going to have here. You will have what A, your D and G, you have what your B, E and what H, you have what C, F and what I. But the next thing you want to do is that even with that you want to get rid of this for now. The next thing you want to do is to repeat what these two columns to add up to what the original matrix. So we will have what we will have A, D, G, and we have what B. We will have B, E, and that of what H and what H. Okay, so you're gonna have these ones coming in the scene. I want to erase this. Okay, so once you have this, the next thing you want to do is to what follow the same approach that we engage in, that of what the determinant of a 2 by 2 matrix. So you find the product of what the downward arrows compared with the product of the upward arrows. Okay, so we're going to indicate some cool arrows to help you to understand what we are doing better. So we will have what, and here too you form the arrow based on the diagonal that give a clear line for you to what, form that arrow. I mean, in terms of the diagonal going to indicate the arrows. So we can clearly see that here we may have what we may have from A, we may have up to what I. So we can see that effects happening here. We can take our first what diagonal, and then we can also take the second one, which is what B, F, and what G, and we can also as well take in the third one, which also starting from C, D, and what H. So once you are done with the downward diagonal, then we go for what the upward diagonals. We go for the upward diagonal. So that one too, we can clearly see from G, E, and what C. So we can form that arrow there. Oh, this one you can't see. Let me use a different one. Go blue, help. Kind of. So we have what you will have this, and then that's of what the second. We start from H, G, and what A. So we have here two coming up as the next thing, and then you also have what from I. I think let me choose a different. Uh, can I go for yellow? So let's say I. Yeah, something like this. We'll go for this. Okay, so once you have the upward and downward diagonal, you find the product of the downward, you find the product of the upward, you compare in between the two, then you are good to go. So we say that our determinant that x should be equal to, so we start with the first one. So we have what into bracket A, E, follow carefully, A, E, what I, plus, then we have the second one, which is what B, F, and what G. Then we say plus the third one, which is what C, D, or H. So you find the product. Then you compare with the upward. You compare with what the upward diagonals. Okay. So we follow through with that too. We will have what this one you can see. Let me go for green. I think green will be okay. Yeah. So upwards we have what G, E, and what C, plus we have what H, F, and what A. Then we have plus I, D, and B. Let me bring that up here. So I think it has already ended. So let me bring the plus here. So we have what? I, D, and what? B. And you are good to go. So this is also how we find what? The determinant of a 3 by 3. So all that you want to do is just repeat the first two columns to extend the original matrix. And after that, you indicate your downward what? Arrows. You indicate your upward arrows. You find the sum of the product of the downward arrows, compare with the sum of the product of the upward arrows, and you are good to what? Go. You get your determinant for that. So this is also how we find determinant of a 2 by 2 matrix and a 3 by 3 what matrix. So you want to take note of that. If you have any question, drop in the chat for us as we move along with the discussion. Okay, so that is also how we find the determinant of what matrix. Another aspect of the determinant of a matrix with respect to matrix application, and I mean generally, is also the issue about inverse of a matrix. How do you find inverse of a matrix? It's very simple. To find the inverse of a matrix, all I want to do is, for example, let's say we have a 2 by 2 matrix, and in this particular video is centered on a 2 by 2 matrix in terms of with respect to finding what the inverse. We'll look at the 3 by 3 matrix later on. For now, go by 2 by 2. So let's say I have what matrix what P to be equal to A. Let me go for my blue. Come in, go for my blue. So let's say I have here to be A, B, C, and D. I'm asked to find what the inverse of what matrix P. Before you can find the inverse of any matrix, you must first find what the determinant. So how do you find determinant? So we say that P. We say that P should be equal to, as usual, the product of what the downward compared with the product of the upward. So we have what AD minus what BC. AD minus what BC. So once we find the product of what AB minus DC, then to find the inverse of what P, so P inverse as a matrix is going to be, this is what we're going to do, is going to be what? The inverse of what? The determinant, which is what? AD minus what? BC. So to find the inverse of A minus, that means that you are going to write like this, AD minus what? BC, all to the power negative 1. And having this means I can write this as what? 1 over AD minus what? BC. As that. Okay. To find the inverse means that you must first find the inverse of what? The determinant. Okay. By that way, you put a bracket on it, you take the power of negative 1. By that, we can write that as what? 1 over AD minus what? BC. So you have what? 1 over 1 over AD minus what? BC. And after that, the next thing you want to do is to interchange the position of what? A and what? D. Interchange the position of what? A and D. So you have what here to be D, you have here to be what? A, and you negate what? B and C. So negative B, negative what? C. This is how we find what? The inverse of what? A matrix. So step 1, you find the determinant of what? The matrix. That is the first step. Step 2, you find the inverse of, step 2, you find the inverse of what? The determinant. By that way, you enclose the determinant and raise it to the power negative 1, which is the same thing as what? 1 over AD minus what? BC. And the last step is that you interchange what? The position of what? A and D. That means the downward word arrow. You interchange their position, and then after you negate what? The upward word entries, which is what? Here we are using B and then C. So you negate what? B and C. So these are the 3 steps that you must follow to find the inverse of what? A 2 by 2 matrix. Any question, just want to drop in the chat for us as we wrap up the discussion. All right, so that is the whole idea that we want to understand when it comes to what? A matrix. So let's take an example to explain that as we move along with the discussion. All right. So that is the whole idea with respect to that, okay? So let's see if we can have an example for that so that we can continue with the discussion. I think I have some. I'm coming. Wait for me for some sec. Get a caution for us to go in that case. All right, let's go. Have some question, but let's go. All right, so let's take in an example to explain the concept better.